Hey everyone, welcome back, and thank you for joining us again in our next discussion of statistics. Jumping to our first objective then, we need to determine the arithmetic mean of a variable from raw data. Our first vocab word then would be arithmetic mean, which would simply be the average. We compute this by adding all the values of the variable in the dataset and dividing by the number of observations. Next would be the population mean, which is mu. This is computed by using all the individuals in a population. Make sure we realize this is a parameter, which pulls back some previous vocabulary. You see the formula that we need to use. Mu is simply adding up all the observations and then dividing by the population size, which we know is capital N. Just in case you haven't seen this symbol before, this is your summation symbol. We'll be using this later, but that just again tells us to take the summation. That again just tells us to take the sum of each individual observation. Each observation would be x sub I, so that would be our x sub 1, 2, 3, all the observations we have. Next we have our sample mean, which we call x bar. This is computed by using the sample data, which makes this a statistic. If x1, 2, all the way up through n are our n observations of a variable, then the formula we use that you see there is x bar, and it looks just like what we had for the population mean, except for now we're dividing by the sample size, which is a bit of a technicality at the moment, but we'll elaborate more on this later. Make sure we realize we will have to do this by hand on the exam though, like you see on your notes. Alright then, let's go ahead and jump into our example. They tell us the following data represent the travel time in minutes for all 7 employees of a startup web development company. We have the data in front of us and they tell us to compute the population mean of this data. Since they say population mean, we know we're discussing mu, and we know mu would be the sum of our observations divided by the total number of observations in the population. This means we need to add the values of our 7 employees, their commute times that is, so 23 plus 36 plus etc., dividing that by the population size, which would be 7. If we use a calculator, we end up with mu equal to 24.9. Let's move on to part B then. Now they're telling us use the sample of 4 employees given below to compute the sample mean. Now remember, sample mean would be x bar, so we need to do x bar equal to our observations divided by the total number of values in our sample. So we have 23 plus 36 plus 5 plus 26, now divided by 4 since that's our sample size. We end up with x bar, the sample mean, equal to 22.5. That takes us to part C. We're asked again to use the sample of 4 employees given below to compute the sample mean, but this time they selected 4 different employees. So we have some different values for our data. We're still finding sample means though, which means we're finding x bar, which means we're going to take the sum of our observations and divide it by our sample size. So we have 36 plus 23 plus 43 plus 26, and we're dividing that by 4. Now just a little side note here in case you're having any issues. Make sure we're careful when we input this in our calculator. If you're doing this all at once, we need to put parentheses around the numerator so that our calculator finds the sum first and then divides by 4. We should end up with x bar being equal to 32.0. Part D asks us, what do you notice about the 3 different means that we found in parts A through C? And all we're trying to recognize right now, so we lay some groundwork for later, is that the means differ as a result of the varying samples. Our next objective has us discussing the median of a variable from raw data, and we want to be able to find this. Now the median, which is m, is the value of the variable that lies in the middle of the data when arranged in ascending order. What this does is it separates or divides the bottom 50% of the data from the top 50%. The steps in finding the median of a data set you see on your notes, where we need to arrange the data in ascending order, smallest to biggest, determine the number of observations, determine the observations in the middle of the data set, but step 3 we need to elaborate a little bit. First, if the number of observations is odd, then the median is the data value that is exactly in the middle of the data set. A bit trickier is if the number of observations is even. That means the median is the mean of the 2 middle observations in the data set. So we have to find the 2 middle values and find the mean of those 2 middle values. Of course, we'll have some examples to elaborate. Again, note, you'll have to do this by hand on your exam. Jumping into our example then, we're asked to determine the median travel time for all 7 employees of the company from the previous example that we discussed. So we've got our 7 employees. Like we just mentioned in our notes though, the first thing we need to do is organize the data in ascending order. So we've got 5, 18, 23, 23, 26, 36, and 43 in our ascending order. What makes us happy is that since we've got 7 employees, we've got an odd number of observations, and we get to find our median by simply selecting the middle value of our data set. Of course, the middle value that I see is a 23, so that means our median is equal to 23. Continuing on to our next example, we're trying to create a comparison between means and medians by working with the same data that we did on the previous example when we found sample means. So now for this first one, they tell us to determine the median of the first sample data from the previous example, but now we're finding the median instead of the means, working with the same data from that sample though. Again, since we're finding median, the first step would be to reorder our data in ascending order, which means we've got 5, 23, 26, and 36. Now since we have 4 individuals, or an even number of observations, remember we need to take the mean of the middle 2 values. So our median, m, would be equal to 23 plus 26, but dividing that sum by 2 in order to find the mean. And we end up with a median value of 24.5. Similarly, going on to number 2, we're asked to find the median again. Need to rearrange the data in ascending order, so we get 23, 26, 36, and 43. Just like we did before, we need to find the mean of the middle 2 values since we have an even number of observations. So our median would be found by adding 26 plus 36, then dividing that sum by 2. Now part 3 asks, what do you notice about the medians found in the previous problems that we just did as compared to when we found the means of the same data? Now when we found the means previously, for the first set of data we got a mean value of x bar equal to a 22.5. For part C, we had an x bar value of 32.0. Then we just found the medians of the same 2 samples, where we got a median of 24.5 and then a median of 31 for the second set of data. The whole point of the question would be to recognize that the medians did not vary as much as the means did. From the first to second sample, we had a mean increase of almost 10, while the medians increased by less than 7. This is just a little introduction to the idea of resistant, a numerical summary, a mean, median, etc. of data where extreme values, whether they're very large or very small, relative to the data, don't affect the value substantially. This will be a concept we discuss throughout the semester. So next we're going to discuss finding the mean and median on our calculators. We have the instructions in the notes like you see. I'm going to jump over to my calculator so we can show the visual as well. Here's our TI-84. Now on your notes, what we're trying to do is simply input values into a list. We're going to use L1 for the sake of simplicity right now. And you see the buttons that we want to hit. The first button I want to hit would be the Stat button. Stat button is just about the dead middle of your calculator. When I hit Stat, you see these options pop up. The next thing we see is to highlight Edit, but notice option number 1 is already highlighted for Edit. So next we're going to hit Enter in order to get into that Edit option, and we have all our lists. After we get into our list, we just want to start inputting our values. The values we have are 23, 36, 23, 18, 5, 26, and 43. And notice that, just like it says in your notes, we need to hit Enter after we input each number. Now we have all our data in L1. Now the next piece, since we have our data in, would be to find the mean in our calculator. You see again the instructions in your notes, so I'm going to go ahead and jump back to the calculator again. Now on our calculator, as you see in your notes, the next action would be to hit the Stat button again, just like we did before in the center of your calculator. When I hit Stat, we see this option screen again. I'm going to hit the right arrow once over to Calc, and notice now they give us different options as we're in a different setting. Like you see in your notes, we want to execute the 1var stats. It's already highlighted on there, so I just need to hit Enter. When I hit Enter, it takes me back to the home screen, if you want to call it that, and we have the 1var stats option ready to go. We want to tell our calculator which list we want to use to execute the 1var stat. So I'm going to hit second over here, and then we're going to hit L1. L1 would be the list that you saw me put the data in, but remember you can use any list that you want. L1 would be the number 1 once we've activated the second. See the little blue options in here? L1, L2, L3, etc. So when we hit second, those options are activated. So again, we hit second and then L1. To execute the 1var stats, we simply hit Enter, and our calculator provides us our results. Now remember our vocabulary, X bar represented the sample mean. This is a bit of a big deal. X bar and mu are the same thing in terms of our calculator. We know X bar means the sample mean, while mu is the population mean. But since mathematically they end up being the same, in the calculator X bar represents either mu or X bar. Your next piece would be to check out the median. If you hit the down arrow, notice this location over here. This tells us that there's more information down there. So if we hit the down arrow, you'll see more information for us to see. And we see that MED represents median, and that would be the median that we found previously. To wrap this concept up real quick, take a look at the note. To clear a list, we need to arrow to the top of the list until the list name is highlighted. Make sure we use the clear button, not the delete button. Going back to the calculator just to show what I mean, I'm going to hit Stat and Edit to go back into our lists. If you want to clear a list, I need to arrow up to L1, hit Clear, and then we're all set. However, if we hit the delete button, meaning I'm going to go up to L1 and hit the delete button, it will delete L1. Notice that L1 is gone. Not a huge deal, we can get it back, but sometimes this makes people feel uncomfortable. In order to get L1 back, I'm going to hit second and then the insert button, which is the delete button. When I do that, it's going to bring up and kind of shove everything to the right. Now I'm going to hit second and then L1 again, and it will bring my list back up when it asks me to create the L1. Jumping to our next topic then, we want to discuss the relation between the mean, the median, and the shape of the distribution we can equate from this. You see in your notes that we have these things labeled out. We've got skewed left, symmetric, and skewed right for our different categories. We know what those mean visually, but let's tie in a little bit of our numerical summaries like we discussed. On our first line, we have the idea of a skewed left distribution. We want to recognize that the mean is substantially smaller than the median. Now, substantially is a bit of a subjective word, but we'll get into that later. If we're looking over here at our first diagram, notice that the mean is to the left of the median. The way I remember this is that I like to think that the mean pulls the skew. So whichever way the mean ends up falling in relation to the median, that's the way that the skew is. To elaborate on that a little bit, let's look over at the third option. If we have a skewed right distribution, then that means the mean is greater than the median, again substantially. So now the mean has quote-unquote pulled the tail, if you will, of the distribution. Again, this is just the way I remember it, but the mean is greater than the median, therefore we've got a distribution that is skewed right. And of course, lastly, if we're looking at the diagram in the middle, if the mean and the median are equal or approximately the same, remember it's roughly equal to the median, then that means we end up a symmetric distribution. The mean is not being pulled left or right, we end up with a symmetric distribution. Our next discussion then would be of the mode of a variable from raw data. Now the mode is the most frequent observation of a variable that occurs in a data set. Notice in our notes, a data can have no mode, one mode, or more than one mode, like you see figure A and figure B with multiple options. If there are two observations that occur with the highest frequency, we call this bimodal. If there are more than two observations with the highest frequency, then the data is considered multimodal. Let's go ahead and jump into our example then. We've got a sample of 30 registered voters. They were surveyed in which respondents were asked, do you consider your political views to be conservative, moderate, or liberal? We've got the results of this, and they ask us to determine the mode political view. Big idea is we need to remember the vocabulary. If we remember that mode is simply most frequent, it turns this into a quote-unquote easy question. Remembering that mode is most frequent means we've got three categories, conservative, moderate, and liberal. So we need to simply count up the frequency for each category. If we're looking at our data, it looks like we've got 8 people who responded conservative. The number of moderates we had was 12, and we ended up with 10 people responding that they consider themselves liberal. Therefore, the mode would be moderate because we have the highest frequency in that category. Next, we have a quick little summary of the measures of our essential tendency. Now, this is just for us to group a summary together so we can compare mean, median, and mode. You see the table in front of you and some formulas. But overall, we just want to remember that the mean represents the average, if you will. Median we know is the middle value of our data, where it divides the bottom 50% from the top 50%. And finally, the mode is simply the most frequent observation. And thank you again for joining us.